Welcome to this course. My name is Dr. Siamak Eliassi. I have more than 8 years of experience in oil and gas consulting engineering, and I have taught this course for over 10 years. This course is one of very few in Canada that focuses specifically on crude oil refining. Throughout the term, you will learn the major units of a refinery, explained in clear, simple language. Before we begin refinery operations, I will briefly show how refinery products can be upgraded in a petrochemical complex to become raw materials for other industries. For example, benzene can be produced from the naphtha cut. By processing naphtha in an aromatics complex, we obtain benzene, toluene, and xylene, commonly called BTX, which are key building blocks for products such as epoxy resins. I will also briefly connect crude oil fractions to familiar industries such as detergents and paints. The goal is to show how central crude oil is as a feedstock for many industrial supply chains. For each refinery unit, we will follow a consistent structure: the fundamentals and purpose, the feed streams and key operating conditions, the process flow diagram, and products. At the end, we will practice simple calculations to estimate physical properties and unit yields. As mentioned, this course focuses on refinery units. On the slide, you see the ExxonMobil refinery in Louisiana, USA. Please note the scale. Compare the main process equipment with the trains on the left side of the image. The footprint is enormous. This is typical of large, integrated refineries. In 2013, I searched for the world's largest companies by market capitalization and found below table. At that time, 7 of the top 10 companies were directly connected to crude oil and refining. When I updated the comparison to 2024, the ranking changes. Saudi Aramco appears as the largest company, while many others at the top are major technology firms. However, by 2024, Saudi Aramco is ranked 8th by market capitalization. Even so, this comparison highlights how influential the energy sector has been historically and how it continues to remain strategically important. Another useful perspective is global crude oil production. In 2020, world production was about 95 million barrels per day, which is roughly 15 million cubic meters per day. During the COVID-19 pandemic, crude prices fluctuated significantly, approximately from $21 to $63 per barrel, using West Texas Intermediate or WTI as the reference benchmark. In 2020, the United States was the largest producer and also the largest consumer. Canada ranked 4th after the United States, Saudi Arabia, and Russia. This gives a clear message. Crude oil remains one of the most traded and economically significant commodities in the world. Now, let us look at the overall technical picture of a refinery. This block flow diagram shows the essential units of a refinery and how they are interconnected. At first glance, it is complex and it is difficult to follow every line. This is completely normal at this stage. In this course, we will study each unit separately. Before we begin a unit, we will return to this overall diagram to answer 2 questions. Where does the feed come from, and where do the products go? With repetition, the full refinery structure becomes clear. By the end of the course, you should be able to connect the units logically without relying on the diagram. You should also be able to propose the key units required for a given crude oil. For example, if a sweet crude with negligible sulfur is processed, extensive hydrotreating capacity may not be required. For each unit, I will first show the unit's location within the overall refinery diagram. As an example, we will begin with the atmospheric distillation unit, which is typically the first major unit in a refinery. As you can see, it provides feed streams to many downstream units. To focus our attention, we will isolate the atmospheric distillation unit and simplify the surrounding context. Now, let us go inside the unit. Even this simplified process flow diagram can look complicated. Therefore, we will build it step by step, starting from a blank slide and beginning at the feed stream. This method makes the flows easier to follow and understand. Next comes the feed pump, followed by the heat exchanger network, and then the remaining equipment. I will not explain every detail at this moment. Instead, observe how the full diagram forms gradually. This is the teaching strategy we will use throughout the course. Let us watch the build sequence. Now, let us return to the overall unit and review what you'll learn across the term. In a petroleum refinery, product blending is a critical operation. Each refinery has its own blending recipes based on its crude feed and the products it targets. Streams are mixed to meet market specifications, industry standards, and customer requirements. However, blending is not covered in this course. Therefore, the tank farm and blending section are outside our scope. Now, let me organize the course units by session. Each session consists of 3 short videos, each under 20 minutes to keep the material focused and maintain attention. In the first 2 sessions, you will learn about crude oil, its composition, formation, extraction, and transportation, petrochemical products, paint and detergent industries, and then we will introduce the main processing categories in a refinery: physical separation, chemical treatment or conversion, and blending, conceptually. In 2 additional sessions, we will review the key physical properties of crude oil and present the formulas used to estimate them. In 1 session, we will review the desalter unit and principles of distillation, since distillation is the most important unit operation in refining. We will then study the atmospheric distillation unit, ADU, in depth across 3 sessions, including straight-run products, their properties, and practical hand calculations using the true boiling point curve. Because heavy fractions cannot be effectively distilled at atmospheric pressure, we will next cover vacuum distillation in 1 session, an essential step in processing heavy oils and in producing lube oil range streams. After separation units, we move to conversion processes. The first chemical processing topic is the light ends section and isomerization, discussed in 1 session, together with its connection to the catalytic reformer. The catalytic reformer will be covered in 1 session as a major unit for improving gasoline quality. By the end, you will also learn simple hand calculations for yield and octane number. To produce high-quality middle distillates, such as kerosene and gas oil range products, we will cover hydrocracking in 1 session, focusing on its use of hydrogen and catalysts at high pressure and temperature. Because most crude oils contain sulfur compounds, and sulfur forms harmful SO2 during combustion, refineries must reduce sulfur to meet environmental regulations. Therefore, hydrotreating will be discussed in 1 session as the key process for sulfur removal and for improving product quality. Finally, since gasoline is a major economic driver for many refineries, we will cover fluid catalytic cracking, FCC, a flagship chemical engineering process that uses a fluidized bed reactor to convert heavy fractions into lighter products, especially high-octane gasoline. In 1 session, we will discuss FCC fundamentals, chemistry, and the flow diagram, followed by 2 sessions of hand calculations using different catalyst assumptions. Near the end of the course, we will discuss 2 thermal cracking units, followed by the hydrogen and amine treating units. For students interested in economics, we will conclude with an introductory session on cost estimation for major refinery units. You may ask, by the end of this course, what should you expect to learn? By the end of this course, you will be able to 1. Map the main industrial production pathways for common organic chemicals derived from natural gas and petroleum fractions. 2. Explain key principles of gas processing and the petrochemical, paint, and detergent industries. 3. Interpret process flow diagrams and describe the function of major refinery units, such as desalting, atmospheric and vacuum distillation, fractionation, isomerization, hydrotreating, reforming, FCC, hydrocracking, thermal cracking, lube oil, and hydrogen. 4. Evaluate how operating conditions affect atmospheric distillation performance using TBP/ASTM D86 curves and crude and product properties. 5. Estimate product yields and specifications using experimental curves TBP/ASTM D86 density for key refinery units. And 6. Analyze fixed and working capital investment for the above units. Thank you very much for watching this session. Please continue with Part 2 of Session 1, where we will cover crude oil composition, exploration, transportation, and an overview of refinery processing.